Hello, today we're still working with inverse trigonometric functions, and I can see I have a rather complicated looking inverse trigonometric statement here. This part of my statement is just asking me to find the sine of some angle. And as I look inside the square brackets, clearly I don't know what that angle is. Inside the square brackets, I see that there was some angle which, when I took the tangent of that angle, produced this ratio. And I know that this is the ratio because clearly this is an inverse trigonometric function, so this is the ratio that was produced by that angle. Now to begin this problem, since I have a ratio that I do not know, I don't know this ratio because it is not produced by a 30, 45, or 60 degree angle, nor any reference angle created by any of those three. It's also not produced This ratio is not produced by a quadrantal angle. So what I've done here is I've drawn a tentative drawing of a right triangle with angle theta here in the corner. And I'm going to say there clearly is some angle in a right triangle that produces this ratio. Since I know I obtained this ratio with the tangent function by comparing the length of the side opposite the angle to the length of the side adjacent to the angle, I'm going to label my triangle 7 for this side and 24 for this side. Now I want to take the sine of this same angle. But to take the sine of this angle, I know sine is opposite over hypotenuse. I'm clearly missing the length of the hypotenuse in this right triangle. I can find the length of the hypotenuse in this right triangle by using the Pythagorean theorem, which says a squared plus b squared equals c squared, where c squared is the length of the hypotenuse. I'm going to say 7 is side A and 24 is side B. I'm going to square both of these, which gives me 49 plus 576. When I add these together, I get 625 is equal to c squared, and to get the length of side C, I take the square root of 625, which is 25 units long. Now that makes sense because I know the hypotenuse is always supposed to be the longest side in any right triangle. Now if I take the sine of this, and I know the answer to an inverse trigonometric function is an angle, if I take the sine of that same angle, I'm going to compare the opposite side to the hypotenuse. So the sine of angle theta is going to be 7/25, and I'm done. That is the answer to the problem, 7/25. Let's take a look at another example, somewhat similar to this. And in this particular example, we're looking at cosine and sine. And again, I'm going to create a theoretical triangle. But as I look inside here, I see that this time I've been given a negative ratio. Again, it is a ratio that I don't recognize from my chart of 30, 45, and 60 degree angles. I know that it's a negative ratio, and I say since this is an inverse sine and this is a negative ratio, this must have occurred from a triangle in quadrant 4, because that's the only place that I get negative inverse sine functions. So I'm going to actually draw this out, and I'm going to put my triangle here in quadrant 4. I'm going to say that this is the angle that is produced. Okay, when I take the sine of that angle, I'm going to get opposite, which is 4, over hypotenuse, which is 5. Now clearly either the 4 or the 5 must have been negative to produce this negative ratio. Since the hypotenuse is never negative, it must be the 4, which was negative in this particular case. To take the cosine of this same angle, and I know that this produces an angle for an answer. To take the cosine of that same angle, I need adjacent over hypotenuse. That means I need to find the measure of the adjacent side of this particular triangle. So again, I'm going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. And since my hypotenuse is 5, I'm going to put it here in place of c. The negative 4 can be either A or B. It makes no difference. So in this particular instance, I'm looking for side A in the triangle. A squared is equal to 16, and 5 squared is equal to 25. When I subtract 16 from both sides, I get 9. The square root of 9 is 3. Is that a positive 3 or a negative 3? Well, if I start here and I go in this direction, I get a positive 3. Now finally, since my triangle is complete, I'm going to be able to take the cosine of this particular angle, and it is positive 3 over positive 5. So the cosine of angle theta is positive 3/5. And there I'm done.